everybody, welcome to the 9.4 part 2 video, which is limits algebraically, and I'd like to clarify some things from last week on this, and I think the best way to do that would be go through some of your exit slip questions from last Friday. So let's get started. I asked you for the first question on your exit slip to find the limit as x is approaching 3, and to find it algebraically, the first thing I would do is plug 3 in directly to see if you can get an answer out. So if I do plug things in directly, I would get 6 minus 5 and 3 plus 8. So it looks as though, as x is approaching 3, the y value that I'm approaching is 1/11. Now, you might remember that a limit does mean what y value you are approaching, not necessarily equaling. So graphically, what that means is if you had an asymptote, that means that the graph is getting close to a particular y value and not necessarily touching it. You could also deal with a hole, like if you're coming up to a hole in a graph, you're getting close to that value, but not necessarily equaling that y value. So we are approaching 1/11. So this one, not too bad. The second example, though, if we'd like to plug and chug first and plug in the -4, something happens here. So we get -4 squared minus 2 times -4 minus 24. In the numerator, we get 16 minus 16. In the denominator, we get 16 double negative plus 8 minus 24. So we would get 0 over 0. And this is called indeterminate form. And as you know, we can't divide by 0. So that means that we can't find the limit this way. So what we have to do instead is manipulate this function and figure out another way that we can write it. And to manipulate, usually, factoring is very helpful. So if I look at the top, that can factor to be x plus 4, x minus 4. Your denominator is going to be x minus 6, x plus 4. And now that you notice this function, you might notice that the x plus 4 is now crossed out. So my reduced function is x minus 4 on the top and x minus 6 on the bottom. And I'm still trying to find the limit as x is approaching -4. Now, if I try to plug -4 into the reduced version, I'm going to get an answer. In fact, I'm going to get -8 on the top, -10 on the bottom, which reduces to positive 8/10. And a lot of you had 8/10 as your answer on the exit slip, which I did count as correct because you understood the question. However, please be careful on a test that you reduce that limit final answer to be 4/5. So what this means is your y value is approaching the 4/5 on the graph. Also, I would like to point out that this logic of crossing out the x plus 4 is really finding a hole. That you're saying that you are approaching -4. You're not necessarily touching it because it's a hole, and you're finding the y value that goes with the x value, similar to something you'll see a little later. The third example on the exit slip asks you to find the limit as x is approaching 9. So, first thing I'm going to do is plug 9 in just to see if we can get things rolling more quickly. Unfortunately, we get 0 on the top and we get 0 on the bottom, so we have that indeterminate form. So as Mr. McConey said in his video, he said, please keep going. And in fact, I could have even said that on example 2, that at this point, after we got the indeterminate form, you want to try to keep going and keep reducing. So if we come back to this third one, unfortunately, we can't factor this. There's no x squared function. So instead, one way that we can simplify this is to use the idea of the conjugate. And the conjugate is going to follow wherever we see a square root. So because the numerator has the square root, I know usually conjugates have to do with denominators, but because the square root is in the numerator, we're going to multiply top and bottom by root x plus 3. My suggestion to you would be to completely multiply out the top, but to not multiply out the bottom. So if I do multiply out the top, I'm going to have to do FOIL. 1, 2, 3, 4. And if I do so, root x times root x is x. Root x times 3 is 3 root x. Then we got minus 3 root x, and then -3 times positive 3 is -9. The reason I don't want you to multiply out the denominator is because you might notice that if we write just everything in factored form here, get root x plus 3, and over here, these cross out, so you're left with x minus 9 on the top, The bottom you have x minus 9 as well, which means you can cross it out, and then root x plus 3 on the bottom also. So if you don't multiply out the bottom, you are going to notice that these cross out, which is great. So now you have a placeholder of 1 on the top. You're left with root x plus 3 on the bottom. But remember, your goal is to find the limit as x is approaching 9. Now that you have a more reduced version, let's plug 9 in now. And if we do that, we get the final answer of 1/6. So as we are approaching 9 on the graph, the y value that we are approaching is 1/6. These problems that I'd like you to try on your own are both new, and I think it'd be good for you to do them. Now first though, before you get into it, I would like to put two things up here. If I give you x minus 2 versus 2 minus x, you might ask yourself, are these things the same? Well, no, because this x is positive and this x is negative. This 2 is negative and this 2 is positive. They're almost the same except for the signs. So if we wanted to make this exactly the same as this, what we could do is take out a GCF of -1, and if we divide these both by -1, the signs would flip. So the x would become positive and the 2 would become negative. And then these two things are almost the same. That logic is going to help you on both this new problem, this first problem 1, and then this problem 2. So what I'd like you to do is pause your video now, get as far as you can on these without me, and I'll show you my answers when you get back. Please pause now. All right, guys, so if you take a look at number 1 here, what I did first was I plugged the 4 into the function. Unfortunately, when I did that, I got the indeterminate form, so I kept going. And I factored the top. Notice that the x minus 4 and 4 minus x almost look the same, except the denominator, you could take out a -1. And when I did that, I got both of these to be x minus 4. So I crossed them out. I was left with x plus 4 over -1. Then I found the limit. I plugged 4 into this reduced version, and my final answer was -8. The y value you were approaching was -8 here. The second example, I did the same thing. I took 16, I plugged it into the original function, but unfortunately, again, I got the indeterminate form of 0 over 0. So I kept going. But this time, to keep going, I multiplied top and bottom by the conjugate of the numerator, because the numerator had the root. So I multiplied by 4 plus root x, top and bottom. I multiplied out the top, but I did not multiply out the bottom. And when I did that, I ended up getting just 16 minus x on the top. And in the bottom, I got x minus 16 and 4 plus root x, because I did not multiply this out. I then noticed what's already circled in red here. I noticed that 16 minus x and x minus 16 were almost the same, except the top, I took out a -1, so it became x minus 16 exactly. Cross these out. Had -1 as my numerator now. My denominator is just 4 plus x because these crossed out. I then found the limit as x is approaching 16 by taking 16, plugging it in here. Got my final answer as -1/8. So guys, feel free to pause and look at these examples again, listen to me explain them again. If you would like to come visit to any Google Meet session, you're more than welcome to come visit if you want to hear these again in more of a live format. Next, I'd like to go over the remaining Exaslip questions for some mixed review. For this question on the Exaslip, I asked you to find these following things. And to find all of these, the first thing I would suggest is to always factor. So the top becomes x minus 5, x minus 4. The bottom becomes x plus 10, x minus 5. And I would highly suggest always finding the domain of your function first, because this is the only one that you find without crossing anything out. Without crossing out. Sorry about my handwriting on here. So this function, if you look at the denominator right now, we know we can't divide by 0 in math. So the two values that would cause your denominator to be 0 are -10 and +5, because you set both of these equal to 0 in your head. So if x cannot be these two values, your domain is everything else but those values. So it'd be -∞ to -10, union -10 to 5, union 5 to infinity. The next thing that I'd like you to find is the holes. And the holes have to do with what you cross out in your function. So because the top and bottom both have x minus 5s, that means that the x value of your whole is going to be positive 5, not negative 5. The reason it's positive 5 is because you set x minus 5 equal to 0 in your head, and you get x equals 5. The question is, how do I find this y value? Well, you might notice that the reduced version of your polynomial is x minus 4 on the top, x plus 10 on the bottom. You're going to take that 5 and plug it in to your function, similar to what we did with the limit problems earlier. You take 5 and plug it in top and bottom, so you get 1/15. So that means when you plug in 5, the y value you're approaching is 1/15. The x-intercepts, or zeros, and vertical asymptotes are both determined by your reduced version of your polynomial. The reduced version is, again, the x minus 4 on the top and the x plus 10 in the denominator. I've noticed this theme over the years. The x-intercepts, or the zeros, is always what's left in the numerator, and the vertical asymptote is what's left in your denominator. So that means that your 0 would be 4, 0, because for an x-intercept, y is always 0. The vertical asymptote represents the line you can't cross. Because we know that x cannot be negative 10, the vertical line we can't cross is x equals negative 10. So here were the answers that I was looking for on the exit slip. It would be a good idea to go back and look to see if your answers were correct or incorrect on your exit slip, to see if this video can clarify anything for you. Last one from the exit slip. Limits from a graph. First things I asked you was to find f of 1 and f of 4. Both of these are asking you to find the exact y value. So, if I would like to find the exact value at x equals 1, there's a hole at positive 1 and a closed dot at negative 1, which means the graph actually exists at negative 1, because that's where the filled in dot is. If I want to find f of 4, there's a vertical asymptote at 4, which means there's actually not any points that actually exist here. The answer I was looking for was does not exist. Some of you answered with infinity. I understand why you answered with that, but this is the exact y value, and there is no exact y value here. All of these, though, is what you're asking yourself, what value are you approaching? What y value are you approaching? So if we look at the limit as x is coming to negative 2, we need to consider both the left and the right sides of the limit. So if we're coming towards this x value of negative 2 from the left, the y value we're approaching is 3. If we're coming from the right, the y value that we're approaching is also 3, which means that my limit exists and it is at 3 because the limits from the left and the right are the same. However, the limit as x is approaching 1, where we're looking here at the x value of 1. If I'm coming from the left, the y value I'm approaching is positive 1. But if I'm coming from the right, the y value that I'm approaching is negative 1. Because the left and the right limits are not the same, this is when the limit does not exist. The limit as x is approaching 4. Again, we have this vertical asymptote at 4, but this time we're thinking, what are we approaching? If we're coming from the left side, the graph is approaching infinity as I get closer to x equals 4. If I'm coming from the right, it is also reaching infinity. So both sides are going to infinity, which means the limit is infinity. I would also accept does not exist, though, because technically infinity is not a y value I can touch. So infinity is a good answer, but D&E is also a good answer. Last but not least, the limit as x is approaching infinity. This is probably the most missed question, I'd say, on your exit slip. What this means is you're looking as x is going to infinity. So you're looking as the graph is going to the right forever, what's happening. As this graph is going to the right forever, it looks like we are slowly and slowly and slowly approaching the x-axis. And the value of y on the x-axis is 0. So the answer I was looking for was 0. Some of you answered this question with the answer of 1/2, which I also accepted because it looked like, if I erase this, it looked like the graph might be approaching 1/2 and not 0. So as your x value is going forever to the right, the graph is slowly and slowly and slowly approaching 0. All right, guys, I hope this was helpful. Again, please look back at your exit slip to see if you can correct any of your mistakes. Thank you.